So it looks like you need a little bit of a review with fractions. Now in this video I will add, subtract, multiply, and divide fractions, but I'm not going to do it in that order. I'm going to start with multiplying. Why? Simply because I think multiplying is your easiest operation. So there's two ways to consider multiplying fractions. I'm going to show you what I think is a little bit more straightforward, but then I will give you a way that I think is a shortcut. So starting with the first option, we are going to multiply straight across. Now you are not going to cross multiply. Everybody thinks that multiplying means cross multiply. That's not true at all. We're going to multiply the 4 times the 3 and get 12. And then we are going to multiply the 5 and the 8 and we're going to get 40. Now what are you going to do with 12 over 40? Now you've got to reduce it. So reducing the top and the bottom by this 4 right here. Why 4? Because 12 and 40, I can see they both reduce by 4. So go ahead and do the reducing. I get 12 divided by 4 is 3. I get 40 divided by 4 is 10. And I've got a final answer of 3/10. But I don't think this was our fastest, most efficient way. Okay, so let's go back to the same problem again. Here's my thought. My thought is, why am I going to multiply and get these big numbers and then have to reduce these big numbers when I can do a little reducing up front? I can see that the 4 on top reduces with the 8 on the bottom. They reduce by 4. Hey, wait a minute. By 4? Yeah, they reduce by 4 right here. So let's do it early on and be done with it. Okay, if I take this 4 and I reduce this 4 by 4, that leaves me with a 1. If I reduce this 8 by 4, that gives me a 2. And why would I want to do that? Because now when I go ahead and multiply across, okay, now I multiply a 1 times a 3, I get 3. And then I go ahead and I multiply this 5 by 2 right here, and I get 10. And oh wait, there's my final answer. So 3/10 still matches 3/10. So do you want to multiply first, reduce second, or reduce first and multiply second? It's totally your call. Notice, I get the same answer. It's just for me, I prefer to work with smaller numbers. Okay, let's look at the next example and I think you'll get why. Okay, so new example, and maybe now you can see why I choose to reduce first. Okay, I definitely do not want to multiply and get 72 over 300 and then be stuck reducing that. Gross. I'm going to choose to reduce first. Okay, I look and I see that the 9 and the 15 both reduce by 3. So 9 divided by 3 is 3. 15 divided by 3 is 5. Okay. Next, I see that the 20 and the 8 both reduce by 4. So 8 divided by 4 is 2. 20 divided by 4 is 5. So on the top, I now multiply 3 times 2, and I've got 6. And on the bottom, I multiply 5 times 5, and I get 25. And there's my final answer. For me, that's easier than trying to reduce 72 over 300. But again, it's a personal preference. Okay, on to dividing. So for dividing fractions, I use something, I try to get kids to remember, KFC, right? Sounds a little familiar, except I'm going to put a math spin on it. What does it mean to divide fractions? Well, the K tells you to keep the first fraction. So the first fraction stays 5/16. Okay, so there's the K, check. Next, the F. The F stands for flipping the second fraction. So we can see 3/8 now became 8/3. So you keep the first fraction, you flip the second fraction. What's the little c? The little c says to change the sign. We change the sign from dividing to multiplying. Now this just becomes a multiplying problem. Again, you can multiply across and then reduce at the end, or I'm going to do a little reducing up front. I'm going to see that the 8 and the 16 reduce to a 1 and a 2. And then I'm going to multiply across 5 times 1 and get 5. And then I'm going to multiply across the bottom. 2 times 3 and get 6. And my final answer is 5/6. So really, dividing is nothing more than multiplying by the reciprocal of the second fraction. The second fraction is the change from 3/8 to 8/3. Flipping it over, that's the reciprocal. So you keep the first one, you take the reciprocal of the second one, or you flip the second one, you change the sign, and dividing is really just multiplying. Okay, so far, hopefully you're thinking, you know what, fractions aren't so bad. But I kind of remember all this common denominator stuff, and fractions used to be way harder. Okay, so now let's talk adding and subtracting. Adding and subtracting, that's where you need the common denominator. Okay, so what does that look like? The first fraction has a denominator of 7. So 7 has to show up in the common denominator. So we can go ahead and throw a 7 into both denominators. But the second fraction has a 5 in the denominator. So now we have to throw a 5 in the denominator of both fractions. So I've got the 7 taken in account. I've got the 5 taken in account. 7 times 5, that's 35. Okay, so how did we get from this 7 to this 7 times 5? We multiplied by 5. So remember, anything you do to the denominator, if you want to change this fraction up, if you do something to the denominator, you have to do it to the numerator as well. So times 5 times 5, 3 times 5, I just went ahead and put the 15 there. Okay, make sure you're with me. To get from the 7 to the common denominator, I multiplied by 5, therefore multiply the top by 5 as well. Okay. So how do I get from a 5 to a common denominator of 35, or 7 times 5? Obviously, I multiplied by 7. So multiply the bottom by 7, multiply the top by 7. 2 times 7, that's where I got this 14. Cleaning this up slightly, I just took the 7 times 5 and made it 35. This 7 times 5, I made it 35. Okay, and look what I've done. I have 15 over 35. I have 14 over 35. What was the point of getting the common denominator? To leave the denominator alone. I have, if I take a circle, think of it and splitting it into 35 pieces. Here I've got 15 pieces. Here I've got 14 pieces out of the 35. So when I add them together, yes, I have 29 pieces, but it's still 29 pieces out of 35. So when you add and subtract, not only do you get a common denominator, when you actually add, you only add the numerators, or subtract if the case is subtraction. Subtract only the numerators. You leave the denominator alone. The only time that denominator changes once you get a common denominator, potentially, is if this reduces, which in this case, it does not. Okay, so let's try one last example. I figured let's be thorough and let's throw a subtraction one on here. So let's subtract. Yes, you need a common denominator. If you're feeling really confident right now, pause the video and try to do this one yourself. So hopefully you're pretty good at getting a common denominator. For me, I know I could just multiply 12 times 8, but I don't like doing that. So 12 is 4 times 3, 8 is 4 times 2. So I'm going to take the 4 and put that into my common denominator. Okay, what's left after I use up the 4? I need this 3 right there. And then I need this 2 right there. So the common denominator is going to be 4 times 3 times 2. 4 times 3 is 12 times 2. My common denominator is going to be a 24. Okay, so for me, I think using 24 is way easier than whatever 12 times 8 is. Now, if you choose to do the 12 times 8, that's fine, but just remember at the end, you're going to have to do some major reducing. So, how am I going to get from this 12 to this 24? I multiply by 2. So multiply the bottom by 2, multiply the top by 2. How do I get from 8 to 24? I multiply the 8 by 3, so therefore multiply the top by 3. 5 times 2 gave me this 10. 1 times 3 gave me this 3. Common denominator is there. Leave the denominator. 10 minus 3 gets me the 7. 7 over 24, again, it just does not reduce. So that is my final answer. So in about 10 minutes, we've done all the major operations of adding, subtracting, multiplying, and dividing fractions. Hopefully, you found this useful.